All right, good morning, everybody. We are on page 14 in the homework packet, which is the Solving Showdown section. So I want you to go ahead and draw a line above problems 38 through 47. These two problems at the top will be assigned. Those are similar to the ones that we did in the last video. So on this next block of problems, we're going to be kind of shifting gears a little bit. So if we look at number 38, what type of equation is this? We see that we have a variable up in the exponent. So this is an exponential equation, which means we're going to want to try to get the same bases. Now, I can rewrite 9 as 3 squared. I can rewrite 100 as 10 squared, but can I rewrite those as the same smaller base? No, we cannot. So we've got a problem on this one, that we can't get the same bases. Now, we encountered this in the note packet. What we do when we can't get the same bases is we are going to log both sides. So this is where we use logging as an operation. So if I common log both sides, I would have log of 9 to the x equals log of 100. Now, if you're looking at that going, all right, so now we have logs there, but haven't we just made the equation more complicated? Or if we think about what we were doing in the previous video, if I cross off those two logs, then aren't I just right back where I started? What putting those logs there allows me to do is that special property of taking an exponent in the answer part of the log and moving it out in front as a coefficient. So what having this x out in front does is it has changed this from an exponential equation to now a ground level x equation. So now that I have x times log 9 equals log 100, how can we isolate this x? We can divide both sides by log 9. And x is going to be equal to there's my calculator. X is going to be equal to common log 100. So your log button next to your 7. I better zoom out here a little bit. Sorry about that. So common log next to your 7. So log 100 divided by common log of 9. So notice especially, folks, that I have closed off that parentheses around the 100, because if you were to not do that, you would get a different answer. So make sure you close off those parentheses around the individual logs. And folks, on these problems where we end up getting non-exact answers, we're always going to carry it out to 3 decimal places. So 2.095. But we look at the 4th digit to see if it bumps up that 5, which it does since it's 5 or more. So this would be 2.096. Now, on this problem, do we have to check for extraneous solutions? The answer is no, because our original equation was an exponential equation, not a logarithmic one. So even though we did get logs involved in this problem, the original equation was not logarithmic, so we don't have to check for extraneous solutions. So our answer is just 2.096. Now, even though we don't have extraneous solutions, it's not a bad idea to just check for correctness here. If I plug this back in and do 9 to that gross little power, so I'm just going to use the stored value on my calculator, we see that it gets us very close to 100. So folks, when we encounter problems where we can't get the same bases, or we encounter base E or natural log, you are always going to round that out to 3 decimal places. So if you can't get the same bases, you log both sides. So let's go ahead and look at number 39 next. Ugh. What type of equation is this one? Because our variable is up in the exponent, this is an exponential equation. So to solve an exponential, we want to first compare the bases, which means we're going to have to isolate this base 4 to see if we can get the same base on the other side. So we would add 6. So 5 times 4 to the x equals 15. Next, we would divide by 5. So 4 to the x equals 3. So this is still an exponential equation. I could rewrite base 4 as 2 squared, but is there any way for me to get the 3 to look like base 2 or base 4? That's going to be a no. So since we can't get the same base, we log both sides. And again, yes, logs are a way of rewriting exponential form, just like square roots are a way of rewriting x to the 1/2 power. So though it is a way of rewriting exponential form, we can also use it as an operation. So I'm going to go ahead and slide common log here, logging in front. And again, folks, this is going to be work that I am looking for. And that allows me to move that x out in front. Now, sometimes students will just forget to write the log there and they'll just move x to the front of 4 and change it to multiplying. The only reason we are allowed to move this from the exponent position is because the word log is there. So it's only by logging both sides that we are able to do that crazy little power rule. So x common log 4 equals log 3. So now I have x at ground level. So x times log 4 equals log 3. We can divide both sides by log 4. And if you're like, well, wait, Mrs. Cairo, couldn't I be fancy and write this in on my calculator as log of 3/4? Folks, that is not the same thing. You can only condense 2 logs that are separated by subtraction or addition. Separated by division, that's as simplified as this expression will go. So it's not the same as log of 3/4. It has to be common log 3, end your parenthesis, divided by common log 4, end your parenthesis. And again, rounding to 3 decimal places, so 0.792. We look at the 4th digit to see if it'll bump it up. 4 is not big enough to do so, so it's simply 0.792. I'm not going to be picky about the squiggle equal sign. I mean, it's technically a good idea because we have rounded it, but you can just say equals 0.792. And again, if you wanted to, you could check by plugging back in. We don't have to check. We're not looking for extraneous solutions on this one because it's not a logarithmic equation. But if I just wanted to check for accuracy, we could do 5 times 4 to the stored value minus 6. And yep, that gets me super duper close to 9. So still solving exponentials like we did on the very first video over the Solving Showdown packet, but now we're encountering things where we can't get the same bases. So now I'm going to leave you guys to do number 40 and 41, but we're going to look over number 42 together, which is going to help you do number 41, where we see good old base E. So first, when we look at this equation, we see base E and we go, well, that's gross. But more importantly, this is another exponential equation because my variable is up in the exponent. So first, let's subtract the 1 to isolate our bases. So E to the 2x equals 54. Now, looking at base E and 54, remember E is that nasty irrational number, so non-terminating, non-repeating decimal, similar to pi. So E is a number, but can I write 54 as base E or E as base 54? That's going to be a no. So it's the same scenario as these previous problems where I can't rewrite these as the same base, so we are going to log both sides. But instead of just common logging both sides, if you have base E, we are going to natural log both sides. So if you have base E, natural log both sides. The reason why we want to natural log both sides is you'll remember in our simplifying rules, natural log and E cancel each other out, so it makes it a little more friendly to type in on our calculator. So if I natural log both sides, still allows me to move this out in front as a coefficient, so 2x. But using our simplifying rule, what's natural log of e? Those cancel each other out and equal 1. So 2x times 1 equals natural log of 54. So 2x times 1 is just 2x. So we would divide both sides by 2. And x equals... Now again, we can't simplify this to be natural log of 27 because this is actually 1/2 natural log 54 or 54 to the 1/2. So simply type it into your calculator exactly as you have it written on your paper. Natural log of 54, close off your parenthesis, divided by 2. And that gives me, rounded to 3 decimal places, 1.994. Now, we could plug it back in to check for accuracy. So to get e on your calculator, you're going to do second natural log. You'll see that e to the x there. So e to the 2 times that stored answer, then plus 1. And we see that, yep, that gets me very, very close to that 55. And older calculators, again, make sure you enclose this in parentheses to ensure the 2 and the x are both up in the exponent. So you can check for accuracy here, but because it's an exponential equation, we don't need to check for extraneous solutions. Alrighty, folks, so on your own, I would like you to try 43. So go ahead and pause the video and try that one on your own, and then we will go through it together. So we identify this as an exponential because our variable is up in the exponent. So our first step is going to be isolating the bases. So subtract 3. So 5e to the x equals 15. Divide by 5. So e to the x equals 3. Can I rewrite e or 3 as the same base? No, we cannot. And because it's base e, instead of common logging both sides, we're going to natural log both sides. So that allows me to move that exponent out in front as a coefficient. So x natural log e equals natural log 3. Natural log and e cancel each other out to be equal to 1. So x times 1 equals natural log of 3. So x equals natural log of 3. And x is equal to, using our calculator, natural log 3 is 1.099, rounded to 3 decimal places. Please check your rounding carefully, folks. It's been a while since you probably had to round out to that many decimal places, so make sure you are checking every digit of your answer very carefully.